Hello guys, so welcome back to my channel, Engineering Chronicles of Plant Design. I have not put video for a long time, sorry for that, and let us discuss today the basics of shell and tube heat exchanger. So in this video we are going to just see not into the calculations or heat balance of the heat exchangers, but we will just go through what the shell and tube heat exchangers are. It's a basic concept of the video, because now once we know the basic, then we go in depth into the what are the calculations required to get the area and the size of the heat exchanger. So let's move ahead. So you know what heat exchanger is. It's a device, it's a static equipment. It is not a rotary equipment, it's a static equipment. So in this equipment what we do is we transfer heat from one medium to another. So for example, if you have a liquid or if you have a fluid, you want to heat up to a certain temperature from temperature A to temperature B. So in that case you will use heat exchanger. So heat exchangers can be used to even evaporate the liquid, to make it evaporation. To You can also use as a condenser. You can condense the vapor from vapor phase to liquid phase. So all this thing can be done in a heat exchanger. So if you see, there are mainly two types of heat exchanger, which is called as recuperative type and regenerative type. So what is recuperative type? So recuperative type means the heat exchanger in which there will be a wall between both the mediums, and they will have the individual environment to work into. For example, shell and tube or plate type heat exchangers, or even a reactor which is having a coil, they all are recuperative, because the heating medium and the cooling medium, they stay in their own environment, in their own pressure behavior. But when we come to a regenerative type, in this type what happens is both the cooling medium and the heating medium comes into a same environment. For example, now you have a big burner, and you have a gas, a hot flue gas going through the and going to environment. So in that case, what will happen is you will use some of that medium to convert your uh, cooling fluid to a heating fluid in that environment itself. So that is also a kind of we call it the regenerative type, because both liquid or both the medium are in the same environment. Okay. So moving on to classifications. So as I said, there are two types: recuperative and regenerative. In recuperative, we have indirect heating and we have direct heating. So indirect heating, if you see, you can have tubular, you have plate, even the reactors which has the coils, the heating coils, the double pipe heat exchanger. All these are indirect type of heat exchanger. Direct type means cooling towers, direct contact exchanger, or steam injector. So cooling tower, you know what cooling towers are. In that case, the cooling water, the hot vapors generally get evaporated to atmosphere, uh, by giving a good big space, big area. So in that case, it is called as direct type of heat exchanger. And also a steam injector. You directly inject the steam into a liquid, into a medium. It is also a recuperative type of direct heating kind of heat exchanger. In regenerative type, there are two: one is static and one is rotary. So we'll not see about much about this type of heat exchanger. We'll only target tubular type of the heat exchangers. Okay. So classification based on the flow configuration. So you might be asking why we want to classify based on the flow classification, because once you design a heat exchanger, when you want to order a heat exchanger, so you want to know always what kind of flow your both liquid has to be, because that is the basis of calculation which is required to find the area of the heat exchanger. If it is a contra-current flow, your efficiency of the exchanger will be very high, very good. But in case of the co-current flow, your efficiency will come down. So always when we design a exchanger, we always try to have a counter current flow. That is the opposite. The heating, for example, the heating medium goes here and the cooling medium goes here. And co-current means both, they will have a parallel direction of a flow, both the liquid. So what is cross flow? So cross flow, what will happen? The liquid will flow from top to bottom, and the another medium will flow from horizontally. This is cross flow. This can be vice versa also. That is why this is called as a cross flow type of heat exchanger. So cross or counter flow. In this case, you can see the picture as defined. This is called cross or counter flow. So based on configuration, we have four types of heat exchangers. Okay. So moving ahead, so if you want to know more about the tubular type of heat exchanger, you have to know what TEMA is. So TEMA is a association which is in USA, mainly in USA, just like ASME. The TEMA has defined some standards to design the tubular heat exchanger. So TEMA means Tubular Exchanger Manufacturer Association. So they have lot of configuration. They have decided to define how to define a heat exchanger, what heat exchanger is, how to size it, and what has to be the overall coefficient depending upon the medium. So all these things they have defined. What has to be the what we say the pitch between the tubes. So all these things is defined in the TEMA standards. So if you want to design the tubular type of heat exchanger, the mechanical design can be ASME Section 8 Division 1. So we call it as UHX section. UHX, that is U stamp. HX matlab HX means heat exchanger in the division. But you can also go to U2 stamp or U3 stamp depending upon the pressure requirement. But it can be mechanically it can be designed with ASME. But if you want to size it properly, then you have to go to TEMA specification or standard. Okay, so see, these are the main configurations. So heat exchanger are always divided into three parts. So you will say what three parts are. So the head, the starting bonnet, the shell, and the end bonnet. Okay. So see, if you have this kind of arrangement in the starting bonnet, this is called A, and this is the normally one pass shell which is used always. This is called as shell type. So this is the shell. These are the configuration used in the shell. These are configuration, and in the rear head, these are the configuration which are used. Okay. So I will show some examples also in these slides. So for example, now in this, if you see that this is the head. Okay. In the previous, if you see, this is the B, and this is one pass shell. The medium goes in and comes out, and this is the end shell. So that is why we call it as BEM. This is B, the shell is E, and this end body is M. So this is two parts because one we have the medium will flow to these tubes first. It will pass down and come out, and from where it will come out. If it is one pass, what will happen? The medium will flow in. It will go through all the tubes and it will come out through the end of the heat exchanger. This is BEM one pass. So we can have one pass, two pass, three pass, four pass, depending upon your requirement. You can decide. So number of passes also increase the efficiency of exchanger. If you want to increase the efficiency of your exchanger, so normally what we do is we increase the number of passes in the exchanger, in the tube exchanger. So in that case, we say that our efficiency of the HE is well maintained. So normally, instead of going for one pass, we always go for two pass, so that we have very good heat exchanging property between both the mediums in the shell and in the tube. So next is AEM. This is this configuration which I showed earlier in the first, that is A, because this is a removable channel type. So this bonnet is called A. Then we have shell same as this, and then we have another bonnet. This is M. So AEM. So same we have AES. So what is AES? So AES, here you have moving type of tubes. So here when we will use this, for example, when you have a medium in a tube which is a very high temperature, and that will have a thermal what we say that very high thermal expansion. So in that case, what we will do, we will use the moving type of, here we'll have some mechanical arrangement. So your tube will be moving inside, so that the expansion is not disturb does not disturb the mechanical design of the exchanger. So all this thing comes into a mechanical design. When you design the exchanger, when you see that too much of thermal fluctuations, and in that case you will go with the AES type of heat exchanger. So AEU. So AEU means you have, this is A, same as this exchanger. Okay, you have removable type of bonnet over here. Then you have same E, one pass shell, but here you have U-tube. U-tube means it will not have, the end of the exchanger will not have a bonnet over here, but your liquid which is going through the tubes, in this tube itself it will have a bend. U-tube comes into a market, it's a ready-made kind of available tubes, and it will come over here and it will come out. This is called AEU, and this is BEU because this is not removable type. We don't have bolting body flange. Here we have bolting body flange. This is A and this is B. Okay, so this is AE, BEU. This is BEU. Or this is kettle type reboiler. You know reboiler, if you see in the process industry, so most of the reboiler are kettle type. We can also have the what we say thermosiphon. Thermosiphon is most probably will be BEM or AEM, but most of the exchanger where you have high temperature evaporation, in that case we will use BKU. This is B, this is B. It is not required you start from the left. You can start from the right also. You can define your exchanger from right also. Okay. So B, then you have K. K is the reboiler. This shell, if you use this kind of shell, okay, this arrangement in the shell is called as K. That is kettle type. So we take kettle type reboiler. So K, and then U means the U-tube. This is some types of some type of the exchanger examples. You know, when you go into the sizing of tubular exchanger or this type, this you will come into this kind of the configuration. Double pipe heat exchanger. What double pipe? Double pipe means, see, we have gone to tubular. This doesn't come into TEMA, but you should know what is double pipe. Okay, double pipe means in the pipe itself, when we say double wall piping. So double wall piping and double pipe heat exchanger both are same. This is mainly used where you have a liquid flowing into a pipe and which needs to be cooled or heated continuously throughout that flow. So we use double pipe heat exchanger, or also called as double wall pipe. Okay. So we can give heating medium or cooling medium in the shell, and your fluid will go through a tube. Plate type heat exchanger. So plate type heat exchangers are very compact inside in design. So why compact? Because the one plate, this whole plate will have a good area, right? So if you calculate the area in this plate, so the dimensions which you will come through heat plate exchanger and tubular will be a vast difference. So majorly, but they have some disadvantages or cons. So for example, your liquid, your medium which you want to heat or cool is very viscous. In that case, you cannot use this type of exchanger. It will get choked continuously. And the medium has to be very clean. Clean in sense like it should not have any contamination. So what will happen, every week or month you have to open these plates and you have to clean the plates. So in that case, you use plate type heat exchanger only when your medium is very clean and you have a very compact space, you have a very less space. You say I don't have a much of a space to put a tubular exchanger, so in that case, or you can also put a plate type heat exchanger where you have very compact in size, but be sure that using this type of exchanger with a clean medium. Okay, so moving ahead with the scrap surface heat exchanger. What is scrap surface? So in your home you have butter, you have mayonnaise, right? So this exchanger is used to manufacture butter. Okay, so what happens is the medium will flow. You have a scraper. You can see the scraper. You have a scraper over here. Okay, in the middle this is rotor. This will move your scraper, and in the outer surface you have heating cooling medium. Okay, so what will happen in the end surface itself? Your medium will get cooled or it will get heated, and you will get it out from here. So in the end surface, now here we will give heating, or in the tube, in the rotor itself, will give cooling or heating. So this is called scrap surface heat exchanger. This is mainly used in the to in a food industry to prepare butter. This is very much used in the preparation of butter or dalda or ghee. Not ghee, dalda also. So dimple or limpet type heat exchanger. So this is a reactor. What we say, if you see, this is a kind of reactor. Okay. So here Dimple means what we'll have a outer layer of the shell with this reactor, and here we'll put dimple. You can see dimple over here, just like a pimple on our face. So we have a dimple, okay. Or when we smile, we have a dimple, right? So same, we have a dimple. This will also increase the area of the heating or cooling medium. And this here, if you see limpet, this is very commonly used reactors in the process industry, where we use limpet. We have a rotor over here inside, agitators, and we have reactor. So this is also a kind of a heat exchanger. So I hope you enjoyed this video. Thank you, and don't forget to subscribe my channel and stay tuned. I'll put more videos about in future on how to size a exchanger, or how to come to a method where you say this is the what we say, the heat balance or the mass balance. No, we will go in detail in the upcoming videos. So thank you, stay tuned. So don't forget to like, share and subscribe. Thanks a lot. Bye. Take care.